definition of an irregular solid is a shape where the volume cannot easily be determined with a mathematical formula, such as a cube or a sphere. First, fill your 50 milliliter graduated cylinder about half full with water. Be sure to record the volume of water that you have to the nearest milliliter. Remember, whenever you're reading the volume from the graduated cylinder, you read from the meniscus or the bottom part of the curved waterline. Do not get your readings from the top of the waterline. Remember, it is the bottom waterline where the arrow is pointing right here. So this one seems to be about 25 milliliters. Record the mass of your water and your graduated cylinder to the nearest milligram. Now you want to carefully slide your irregular solid into water. You want the volume of the water to rise more than 4 milliliters. Be sure not to splash any water onto the sides of the cylinder. It could give you inaccurate new volume readings. If you see air bubbles at the bottom or in any place in your cylinder, you can remove them by gentle shaking. Go ahead and record the new volume in your graduated cylinder. Be sure you're reading the bottom of the meniscus, which is right here at 30, and not the top, which is just in between 31 and 30. Remember, read the bottom of the meniscus. So our new volume is 30 milliliters. Record your mass once more with your graduated cylinder, your water, and your irregular solid to the nearest milligram. So ours is 144.278. You want to do this exact procedure one more time to be sure your readings are accurate and to find an average. Here are the values we got for the density of an irregular solid for our first experiment. Our graduated cylinder and water mass came out to be 88.827 grams, and the start water volume was 25 milliliters. Now we're just going to do two significant figures. We're not going to use any decimal points. That's the general practice when you're doing the density of an irregular solid. And so once we added the solid, we got 144.278 grams as the mass. And our final water volume we made out to be 30 milliliters. So the total mass of the solid, by subtracting 88.827 from 144.278 grams, came out to be 55.451 grams. And the volume of the solid, which is the difference between the two water volumes, was 5 milliliters. Now, using this information right here, we can find the density, and density, as you know, is mass divided by volume. So our mass we got was 55.451 grams divided by 5 milliliters, and it turned out to be, the exact value that we got was 11.0902 grams per milliliter. But because of our significant figures, we only need one significant figure for this equation right here, and so we're going to put that as our value that we're going to be using for further calculations as 10 grams per milliliter. After you find the density of your first experiment, you want to run the experiment one more time and find the density again, which the exact values ended up being a little bit different, but once we use significant figures, they both turn out to be 10 grams per milliliter. And using those, we are going to find the average density. So the first experiment's density was 10 grams per milliliter, plus the second experiment's density was 10 grams per milliliter. You're going to divide that by 2, and we end up with an average density of 10 grams per milliliter. Once you have found the average density of your irregular solid, you're going to find the percent error. Now, percent error, as you know, is found by the experimental value, which is what we calculated in lab, minus the accepted value, which should be given to you in your lab handout, divided by the accepted value, and you're going to multiply that by 100%. So we have 10 grams per milliliter and minus 11.350 grams per milliliter, which is the accepted value, divided by 11.350 grams per milliliter. And once you times that by 100%, you get about a 9% error. Remember that the closer you are to 0 for your percent error, the more smoothly and accurately you ran your experiment.